Okay, so we're going to talk about carbon footprints a little bit today. So most of the information in this came from a book called How Bad Are Bananas? The Carbon Footprint of Everything. So a carbon footprint is the best estimate of full climate change impact of something. Carbon, we're usually talking about carbon dioxide or carbon dioxide equivalents, not actually just carbon. And the footprint is the total impact. So the total climate change impact of all greenhouse gases caused by item or activity. So here's an example. This is a chart showing how this works. It shows most of there's transportation, electricity and heat, industrial processes, all that kind of thing. So this is the kind of thing we're looking at. You can see it's pretty complicated. Carbon dioxide is this section here, and then there's methane, nitrous oxide, things like that. Okay, so it's a little more complicated than you just think. The direct emissions of an item are the manufacturing process, transporting the item to the retailer. Indirect emissions are everything else. So for example, an office in a factory that makes paper clips has paper clips of their own that had to come from somewhere. And that's everything in the office that they have to do to make the paper clips adds into the carbon footprint. That's indirect. So let's give you some context for these numbers. 1 gram of carbon dioxide would be made if you burned a pea-sized blob of gasoline. So that's 1 gram of carbon dioxide. A kilogram, or about 2 pounds, is if you burned 2 cups of gasoline. And a ton of carbon dioxide would be produced if you burned 60 gallons of gasoline. The average American has a carbon footprint of 28 tons of carbon dioxide per year. Now the global average carbon footprint for the planet is 6 tons. So we're way higher than most of the world. So, which do you think would have the highest carbon footprint for riding a bicycle for a mile? Air freighted asparagus, bacon, or bananas? What do you think? Let's go over it. So if you're going to bicycle a mile powered by bananas, it would be 65 grams of carbon dioxide. So if all you ate was bananas for your energy, you would produce 65 grams of carbon dioxide. That would be your footprint. Cereals with milk, it's 90 grams of carbon dioxide. Bacon, 200 grams of carbon dioxide. Cheeseburgers, 260 grams of carbon dioxide. Air freighted asparagus, 2,800 grams of carbon dioxide. So you can see there's a huge difference in the carbon footprint of our foods. We'll talk later why meat is so much higher than the bananas and milk. Air freighted asparagus is because it's being shipped by the air, through the air, and it takes a lot of fossil fuels, produces a lot of carbon dioxide to do that. So what do you think about this? Would the carbon footprint of manufacturing a new car be this very small, roughly equivalent, or very large compared to driving the car over its lifetime? No points on this question. It's just to see what you think. So a new car. Here's a couple of different versions. A Citroen, basic specs, 6 tons of carbon dioxide. Ford Mondeo, 17 tons of carbon dioxide. Land Rover Discovery, 35 tons of carbon dioxide. The CO2 emissions associated with producing the car are comparable to the CO2 emissions out of that car's tailpipe over its lifetime. So it actually takes almost as much, about the same amount of carbon dioxide to make it as the car produces from the gasoline it burns over its life. That's something we don't think about very often. We might know that when we drive, we produce carbon dioxide, but you don't think about how much was involved in making the car. And this is from mining the metal and from producing the plastic and running the factory, all of those things. What about a web search? Google estimates that 0.2 grams of carbon dioxide are used for the electricity. Let me start over. Google uses about 0.2 grams of carbon dioxide for the its electricity when you enter a search term. It's about 0.1 grams of carbon dioxide for 20 seconds of use from an efficient laptop. Network and servers in that 20 seconds are going to use about 0.1 grams. Maintenance on the whole system, replacing parts, etc., doubles the figures. So doing a Google search takes about 0.8 grams of carbon dioxide, produces about 0.8 grams of carbon dioxide. Desktop computers use more power, about 150 watts, so about 0.75 grams of carbon dioxide for 20 seconds of use. An increase in maintenance and network carbon dioxide, total 4.5 grams of carbon dioxide. Google's part is only about 4% of that. So what if you search the web nonstop for a year? You would produce about 5 tons carbon dioxide. This doesn't include wearing clothes, keeping warm, burning calories, getting closer to your next need for medical attention from sitting still for a whole year, living in a building that needs maintenance, all of that type of thing. Okay? What about walking through a door? Well, if it's an automatic door, 6.5 feet wide by 8 feet high, it stays open for 18 seconds. The power from the electric motors is 1 gram of carbon dioxide. If the temperature inside is equal to that outside, then that's it. But if it's cold outside, about 20 degrees, then the footprint jumps to 84 grams of carbon dioxide because of the energy required to heat the air. So just walking through a door in the wintertime, produces 84 grams of carbon dioxide. What about bananas? Bananas have a very low carbon footprint compared to other foods. They're grown in natural sunlight, not in a heated greenhouse. They don't spoil quickly, so instead of shipping them by plane, you can ship them by boat, which is 1% of the carbon footprint of flying. There's no packaging. So total 80 grams of carbon dioxide have shipped across the world. Not too bad compared to other foods. What about spending $1? In our current energy system, it's very difficult to spend $1 without it adding to your carbon footprint. Exceptions would be spending on something that reduces net emissions. So it could be minus 220 kilograms or 485 pounds of carbon dioxide on a well-executed rainforest preservation project. If you bought solar panels, it'd be minus 2 kilograms, 4.4 pounds. In the middle of the spectrum, spending on groceries. $1's worth of groceries is about 620 grams of carbon dioxide. Flying is the worst. It's one of the heaviest carbon emission things you can do. So $1 worth of a plane ticket is about 22 pounds or 10 kilograms of carbon dioxide. Okay, what about a road trip? Let's say we're going from Farmington to Los Angeles, about 800 miles. If you're going to bike and only eat bananas, you'd produce 117 pounds of carbon dioxide. A bus Just a little bit worse, 146 pounds. A small efficient car, 330 kilograms or 728 pounds. A plane, 1,100 pounds of carbon dioxide. A large SUV would be about the same as a plane. £10 of trash. The average U.S. citizen sends 1,250 pounds of garbage to landfills every year. And the average citizen recycles 640 pounds of garbage each year. Landfill emissions are produced when the garbage decomposes, produces methane. Sending metal, glass, plastic, and paper to landfills rather than recycling them forces new materials to be produced for future products. And it takes much more energy to make a new product from raw materials than it does to make one from recycled materials. So, different kinds of trash. Garden waste, about 2 pounds of carbon dioxide. Average trash, about 7 pounds. Aluminum and copper, 90 pounds. What about leaving the lights on? If you left your lights on continuously for a year, how much carbon dioxide would be produced? Depends on where you are. Iceland gets almost all of its electricity from fossil fuel-free geothermal and hydroelectric power plants, so it wouldn't produce any carbon dioxide at all. The US produces much more of its electricity from fossil fuels. We currently get ours from coal. That may be changing soon because our coal power plant is closing down, but at the moment we get ours from coal. So, assuming US electricity generation, a low energy bulb, if you left it on for a year, would produce 198 pounds of carbon dioxide. A 100-watt incandescent bulb for a year would be 1,100 pounds of carbon dioxide. Okay, having a child. The decision to reproduce ends up being one of the biggest carbon choices people ever make, because your child is going to have its own carbon footprint and over the course of the child's life. Assuming the child lives to 75 and assuming the child lives a nationally typical lifestyle, assuming the greenhouse gas emissions are reduced in the coming decades, having a child produces, you're giving birth to an individual who will produce 700 tons of carbon dioxide. 150 tons for a carbon-conscious child. 2,000 tons for a high-impact child. So a large range, but this makes sense that if you count your child's carbon impact over that child's life, that would be a large impact on what your carbon footprint would be. But you can do worse. If you choose to start a forest fire, please don't. But if you did, this is one of the only decisions you can make that has a larger carbon impact than having a child. Your lifetime carbon footprint would increase by thousands of times. The 2008 California forest fires released 231 million tons of carbon dioxide. And a big portion of that will be taken back as the forest regrows. But until then, there's an extra 231 million tons of carbon dioxide. A bottle of water. This is a big thing. We drink way too much bottled water. So most emissions come from packaging and transport. 80 grams of carbon dioxide just from the plastic. So if you get locally sourced and using local distribution, it's only about 110 grams of carbon dioxide. If it has to travel 600 miles by road, and I'm pretty sure most of ours travels a long ways because we don't have local water bottling companies here. If it travels 600 miles by road, it's 215 grams of carbon dioxide. Keep in mind, Fiji water travels 9,050 miles around. A lot of that's by ship, which has a lower carbon footprint, but it still has to travel from the ports to wherever you buy it. Bottled water is 1,000 times more carbon intensive than tap water. The world consumes 53 billion gallons of bottled water a year, which accounts for 0.6% of our total world greenhouse gas emissions. The funny thing is, bottled water is usually not as healthy as tap water because it doesn't have to be inspected near as much as tap water does. So you'd be better off getting you a good bottle and just filling it from the tap. Let's talk about Fiji water specifically. The plastic for the bottles is shipped to Fiji from Thailand. And then the water is transported on ships around the world. Their electricity comes from diesel engines. And on top of all of that, about 12% of Fijians don't have access to clean drinking water, and yet they're shipping this bottled water all around the world. We throw enough plastic water bottles away each week to wrap around the world 5 times. You can imagine that. If you lined all the water bottles that we throw away in a week up on the ground, you could wrap it around the world 5 times. That's a lot of plastic. Okay, let's talk about 2.5 acres of deforestation. 32 million acres of rainforest are cleared every year, and that's 17% of all human emissions. 35 to 45% of this deforestation is for small farms, 20 to 25 is for cattle grazing, 15 to 20 for intensive agriculture, 10 to 15 for logging, 5% is other things, building houses, mines, roads, that kind of thing. So 2.5 acres is also called 1 hectare. This is how big it is, just a little bit bigger than, looks like it's a soccer field. It's equivalent to driving the average car 28 times around the world. That's how much carbon dioxide is produced from cutting down 2.5 acres of forest. Burgers. Everybody loves hamburgers. So, the energy that you use to live and move around came from the sun, which is the most efficient way to transfer energy from the sun to you. From sun to corn to cow to person, or sun to corn to person, or are they equal? It's actually way more efficient to skip this part. Eating vegetarian is a lot more efficient as energy-wise than eating meat. And I do eat meat. Meat is an important part of your diet, but we probably don't need to eat as much as we do. Animal products tend to be more carbon intensive than vegetables and grains because animals need a lot of energy to keep themselves warm and move around. We'll talk about this when we do ecology. Converting animal feed into meat and milk is inherently inefficient. You remember from biology, only 10% of the energy that goes into the animal stays in the animal. The rest is used for energy, moving around, that type of thing. In addition to being inefficient, cows and sheep are ruminants, so they belch methane. Beef and lamb has double the carbon footprint per kilogram of meat than pork does. Excessive demand for meat provides an incentive for deforestation to provide grazing land. So a beef cheeseburger is equivalent to 5.5 pounds of carbon dioxide. A veggie burger, about 2.2 pounds. If you ate nothing but cheeseburgers for a year, your carbon footprint from food would be 4.6 tons of carbon dioxide. All right, using a cell phone. This depends on how you use it. So what are the parts of the footprint? Making the phone is about 35 pounds of carbon dioxide. Power over 2 years is about 13 pounds. Energy required to transmit calls around the network, 146 pounds. A 1-minute cell-to-cell phone call has about the same carbon footprint as an apple. So these numbers change a lot. I had to change them from the last time I presented this. As of 2009, there were 2.7 billion cell phones in use, almost half the world. Cell phone calls account for 125 million tons of carbon dioxide, 0.25% of the global emissions. Texting is a much lower carbon option. In 2014, there were 6.8 billion phones, and today there are 14 billion phones. I need to look this up because that's more phones than there are people on the planet, and I don't twice, so I don't think everybody is using two cell phones, but I'll look that up. This is what Google says, that there were 14 billion cell phones only being used today. A year's typical usage of just under 2 minutes per day, 47 kilograms of carbon dioxide. A year's usage of an hour per day is 2,760 pounds of carbon dioxide. This book was written about 10 years ago, so I don't think there's too many people that use a phone just 2 minutes a day anymore. And an hour per day is probably on the low side. A computer. So 2010 iMac that took 720 kilograms of carbon dioxide, 1,590 pounds to make it. The consumption is about 0.2 pounds per hour. Servers and networks is another 0.1 pound per hour. Overall computing may be only a few % of your carbon footprint. Most of the manufacturing footprint comes from the microprocessor. There's lots of rare metals and things like that, and a lot of different things that take a lot of carbon dioxide to make. Electricity emission typically equal the footprint of the manufacturer after 15,000 hours, which would be 9 hours a day for 5 years. So again, making it takes a lot more carbon than running it. Flights. This is one of the highest ones. Economy class, 3.4 tons of carbon dioxide. Average class, 4.6 tons of carbon dioxide. First class, 13.5 tons of carbon dioxide. One trip is equal to 340,000 disposable plastic bags. First class tickets are particularly high in impact because the seat uses up more of the plane, and by paying more money, you provide more of a commercial incentive for the flight. So when a 747 takes off, about a third of its weight is fuel, and as the fuel burns, it creates 3 times its weight in carbon dioxide. So here's how it works out. A forest fire, of course, is the highest thing you can do, having a child. 2.5 acres of deforestation, then you get a new car, a flight, say LA to Spain, new computer, road trip. This says Pearland to New Orleans from where I taught last time, but say Farmington to Los Angeles. Leaving a light on for a year, $100 of groceries, moderate cell phone use, 10 pounds of trash, a beef cheeseburger, a bottle of water, cycling a mile, a banana, walking through a door, and a web search. That'll just kind of give you an idea as we go forward towards calculating our carbon footprint. Okay, well, have a good day and stay safe.